Hey, thanks for coming. This is the DevOps and software delivery in a global pandemic, or how I think it's called how a global pandemic can help you understand better practices for DevOps. I think is one of those terms, a bunch of little words all thrown together, and hopefully that's the talk you're here for virtually. I am currently my name's Jeremy. I'm at All Things Open, but instead of standing in front of everybody and having them all walk around me, I'm actually just sitting in where I'm staying to give you the talk here. So thanks for joining me. Let's go ahead and kind of get to it. So before I get too far into kind of what this looks like, I want to call out the immensely important State of DevOps reports that go out. In fact, the latest one just came out very recently. Definitely encourage you to go get those. Check it out, read into it. They're all very highly valuable, and they've helped to drive the important practices and behavior shifts that we have in the industry. The big difference between the report that we do and that we've done the last couple of years, and we have a new one coming out here just after the first of the year, is that these other reports, they're industry reports. They're largely based on survey data and based on and as surveys go, kind of potentially biased by the memory of the engineers who take the survey and who choose to participate. It's kind of like when in surveys, often when we take them, we fall into the trap that John Allspaw once tweeted of work as imagined versus work as done, or as we like to call it, performance described versus performance derived. So given that our platform, I work for CircleCI, is used to perform many of the activities that tend to be associated with high performance teams, it allows us to really measure the actual behaviors that is being performed to get a better understanding of how actual engineering work gets pushed through the pipeline. It's like, did the developers actually push code as often as they claim they did today in that survey, or how long are their workflows actually taking them? So again, my name is Jeremy Meiss. I'm the director of DevRel and Community at CircleCI, and you can follow me on I am Jerdog on Twitter. And again, just glad to be here at All Things Open. So let's do this. So at CircleCI, that'll be the second time I say it. I may say the company name again here, but won't be much about it. We have massive amounts of unique data. And that data has how technology delivery teams behave in the wild, how they're actually working. The report examines over 55 million data points from more than 44,000 organizations and over 160,000 projects, which tends to make it about 1,000 times larger than any other survey that's out there. And so we started looking at all this data in 2019 and start trying to figure out how we could slice it and dice it and kind of get to a report that could kind of show how teams are working. And then in this last year, with the world, really the last year and a half, the whole world changing, we really wanted to kind of see what had changed with how developers were working. And we don't believe in one size fits all success metrics for delivery. Every team's different. So the software delivery patterns that we observe in our platform, especially the data points from the top performing, top delivery teams, they show a lot of key similarities that suggest valuable benchmarks for teams to use as goals. So while we're not going to say, there's this one size fits all, we have identified some valuable benchmarks and that can help you and your teams, like I said, use as goals to be successful. So one of the big things that we offer was a set of baselines in our report. Was a set of baselines for the 4 metrics that are related to CI, which is continuous integration, that we think are most important for developer teams to track. So as far as like measuring velocity and engineering efficiency on their teams, these would differ slightly from the 4 classic metrics, which I mentioned here. So kind of the classic metrics for software delivery is deployment frequency, lead time to change failure rate, recovery from failure, kind of those, the classic metrics. But as we looked at the data, we really identified some benchmarks for high performance teams performing continuous integration. That would be throughput, duration, success rate, and mean time to recovery. And I'll touch, the numbers are listed here, but I'll touch a little bit more on those as we dive deeper into the data. So let's get to that data. Now, throughput, we define that as, that's the average number of workflow runs per day. A workflow is triggered when a developer makes an update to the code base in a shared repository. So, a push to your version control system, commonly referred to as VCS, will trigger a CI pipeline that contains that workflow. So the number of workflow runs indicates how many discrete units of work move through your application development pipeline. One of the components of throughput reflects the size of your commits. Are you pushing many small changes or fewer large changes? And so as we thought about it, we thought that, how often do you commit? That would be something we'd really want to think about. But then we realized that commits sometimes can be grouped together and pushed into CI at once, instead of, every time you push a commit, immediately push it to your, to CI. And they're not always running all at the same time. So the right size of how big a commit is or how big a push is really going to depend on your team. But the goal is to have units of work small enough that you can debug quickly and easily, but large enough that you're deploying a meaningful change. You don't want to just go with the idea of, well, let's have units of work small enough so we do 5 lines and we push it. Like that's not a good example of a good metric. But you also don't want to have large enough that it's been weeks that you have been working on something and then you finally push it. That makes it hard to debug that quickly or very easily. So it's important to kind of find that right size for your team. But that is a very much a team effort. So as we look at the data between 2020 and 2019, we saw that the 50th percentile, people are triggering CI 0.7 times per day, which isn't a lot and is a slight dip from 2019. But if we look at the 95th percentile, you start to see like a lot of increased activity at 32 times a day. Which that's a lot. And it's definitely a lot of a big difference from 0.7 times. But the mean here really kind of shows that projects are primarily sitting at about 8 times per day versus just under 6 per day in 2019. So it went up a little bit in 2020 as to how often they were pushing today. So kind of what that was showing us is that throughput and deployment frequency are a different things, and both have been taken as a proxy for for productivity. And so this can be misleading. For example, one thing we don't explicitly measure in throughput is whether a deploy occurred. So you might have done a push, but maybe you didn't deploy it out to your system. So even the scenario of many deploy workflows per day doesn't indicate that there's meaningful work getting done. You can push small inconsequential changes to increase this number and kind of game the system. And that we want to try and avoid that kind of filtering into these results. And so most projects just are not really deploying dozens of times per day. They're not even validating their software dozens of times per day. So while it's not untrue that a description of a high-performing team is one that deploys a lot of projects, it just means that it may be one project that's really moving that fast, but a whole bunch of other projects that they have really aren't moving that fast. So, looking at the total sample of everything going on within an engineering department versus maybe just the primary thing that a developer is working on. A particular number of deploys per day is not really the goal here, but continuous validation of your code base via your pipeline is. So that's throughput. Duration. So we define duration as the length of time it takes for a workflow to run. It's the most important metric in the list because creating that fast feedback cycle hinges on duration. In other words, you can't push a fix, even a much needed one, faster than the time it takes your workflow to run. So duration also represents the speed that your developers can get a meaningful signal from. Like, did my workflow run pass or fail? A short duration requires that your workflow is really optimized. Now, not all workflows produce the same end state. For instance, some workflows, they only run a specific test depending on one part of the application code base that might have been changed. Duration, therefore, is not this explicit measure of how long it takes to deploy to production. It's just a measure of how long it takes to get a workflow's conclusion. The ultimate goal of continuous integration is fast feedback. A failed build signal needs to get to developers as soon as possible. You can't fix what you're not aware of. But awareness is not really the only consideration here, because developers also need information from their failed builds. Getting the right information comes from writing those really rigorous tests for your software. It's important to emphasize here that speed alone is not the goal. A workflow without tests can run quickly and return green, but that doesn't tell you anything because there's no tests. Naturally, it's going to return green. And that signal is not helpful to anyone. So teams need to be able to act on a failure as quickly as possible, and then with as much information as they can get from that failure. Without a quality testing suite, workflows with short durations aren't really contributing valuable information to that feedback cycle. So the goal is really to have rich information combined with short durations. Okay, so with the data, we saw in 2020 that 5% of builds finished in less than 12 seconds, which when you think about 5%, it doesn't sound like very much. But if you remember, we're talking about large builds. And so in that sample, 5% represents at about 500,000 builds in that sample. So that itself is not a small number. So then begs that question of, what can you get done in 12 seconds? If 5% of the builds are finished in less than 12, like what could you really get done? The answer is probably not a lot. But some people, in some devs, you could probably do a lot in that time frame, or at least a bit. If you have many unit tests that you can kind of parallelize, I'm use that word a few times, I better get used to it. Or maybe you run a whole unit test suite. If you're uploading an artifact into an S3 bucket to get it ready for deployment, you can probably do that in less than 12 seconds. So that would be a valid, kind of piece that could finish in 12 seconds. But in 2020, the 50th percentile here kind of pegs it right around the 4-minute mark. And as a developer, if you're getting good quality feedback 4 minutes after you've pushed the software, that can be a game changer. But the 95th percentile is at the 34-minute mark. And for a lot of companies, depending on what they're doing, the test scenarios and whatnot, that 34-minute mark is probably a good place to be. But what we're seeing is that half of all the builds are finishing in 4 minutes. Now, compared to 2019, we're not seeing a lot of movement. The durations are going up just a little bit, but usually that usually indicates that a bit more testing is happening. All right, so next thing, success rate. Success rate is defined as the number of passing runs divided by the total number of runs over a period of time. Who knew we were going to have to do math here? Git flow models that kind of rely on topic branch development versus like default branch development, they enable teams to kind of keep their default branches green. And so one important thing to note here is that we expect to see a high variability of success, depending on whether the workflows run on the default or the topic branch. And in many Git flow models, topic branches are where the majority of work is done. And therefore, the majority of signal generating, passing, and failed experiments are there as well. So by scoping feature development to topic branches, we can start to differentiate between intentional experiments where a failed build, it's valuable, it's expected, you're able to learn from it and build on it. And then stability issues where failing builds are undesirable, where it might be in a default branch where a failing build, you don't want to have that. So success rate on the default branch is a more meaningful metric than success rate on a topic branch. Now, as we look at success rate, we're looking at how often does your pipeline complete with a green status. A pipeline can complete with either red, green, or error. And error really just means incomplete. Something couldn't be done. It could be an external resource was not reachable, or you were putting in, an impossible scenario, or, like a test divided by 0 and everything just shattered. So for us, a success rate at the 50th percentile, we're seeing 61% of all pipelines are passing in green. When you look at the lower end of that data, those numbers become less meaningful. And because there's a group of things that never fail, and there's a group that always fails. So when you throw those out and you just look at the middle, you see that roughly half of all builds are passing. So what this tells us is that a lot of people are just testing out projects. They're dabbling with CI. And so how many of us have, and not a show of hands because this is a webinar, but or a virtual talk, but how many of us have started up a project over the weekend, started messing around with building it, get distracted, and then haven't gone back to that project? I know I have. Heck, I have, I think at last count, 24 domains that I created for said projects, and they are still sitting there doing nothing. So we really didn't see much difference between 2019 and 2020 around kind of the success rate. Now, mean time to recovery we define that as kind of the average time between failures and their next success. It's the second most important metric in our list. After you get a failed signal to your team, their ability to address the issue quickly is invaluable, because mean time to recovery improves with more comprehensive test coverage. So this metric can be a proxy for how well tested your application is. Failed build, valuable signal, rapid fix, passing build. So that's how you want to see things happen. Continuous integration makes these rapid feedback loops possible. That fast signal also enables teams to try new things, respond to kind of any impact that is there, and respond to them immediately. Likewise, solid test coverage reduces the fear of introducing broken code into your production code base, and allowing you to challenge your engineering teams to be creative and really nimble with the solutions that they're out there developing. So the 50th percentile, we see 2 minutes that it sits in a failure state before it's recovered, which is just under about a minute improvement from 2019. A lot of times in those scenarios, that could be from multiple contributions running in parallel, where developer 1 pushes a bad commit, developer 2 pushes a good commit. The bad commit fails really quickly, but then with the good commit succeeding right after. Or it could be the same developer. I know I've pushed something, realized quickly what I broke, and just pushed the fix immediately. And all of a sudden things were great. I recovered really quickly. We're not even going to go into the rabbit hole of commit messages that would indicate my struggles there. Now, at the 50th percentile, as we look at the data, we're seeing about an hour until it's recovered properly, an improvement of 3 minutes from previous year. And then from there, you start to see things that are probably more attributed to some code is getting pushed, and then you go home and you come back the next day to check it. The mean here is at 14.85 hours, which really kind of illustrates that. It's about the time the end of a workday to the start of the next day. And then if you see at the 90th and 95th percentile, where it looks like people just kind of go home. We're seeing improvements for the most part, but this going home bit is really interesting because it tends to kind of go against the classic kind of continuous delivery philosophy where you don't go home if the build's red. But there's also some pragmatism here that as you're analyzing the build, is it really the most important thing? Maybe it's just a test build. Maybe it's a feature branch, and it doesn't matter if that feature it breaks because it's not in your actual production branch, your main branch, or your default branch. So not going to judge on someone's work habits, going home to come back the next day and check on the build and fix what didn't. We're not going to make any judgments there. So overall, in 2020, we've seen recovery time definitely decrease, and it's moving in the right direction. We can hypothesize on this a little bit, say that maybe more people are at home, more attentive to what's going on with the code, maybe less stepping away from the office for a cup of coffee or, go see a movie or that kind of thing. All right, so now I'm going to kind of jump into the insights that we've gained from this data. And so it really, as we can start to compare the last 2 years of reviewing the data, what we can kind of get from it. And then towards the end, I have some things that we've just started to see as we're starting to analyze the data from the latest report that will be coming out in 2021, just after the first of the year. All right, so at this point, it really goes beyond saying that 2020 and really the last 18 months or so has been a period of time like no other. We can't look at the data that we've seen so far without thinking about the impact that a global development has, or global pandemic, not global development, global pandemic has on DevOps and software delivery, and how has it affected team performance. So year after year, we hear in the industry that high-performing teams are deploying dozens of times per day. And while those stats can really make for some great conference talks, meetups, and whatnot, our data doesn't corroborate this metric. We don't see workflows being run at this rate by the vast majority of teams. Now, with the data that we have from March to May of 2019 on the left side of this graph, March to May of 2020 in the middle, and on the right is our August 2020 data. And that will be the same throughout all of these graphs. So for many of the percentiles, we see a slight dip as the pandemic was hitting in that March, April. And then the maximum was reached in April of 2020. Now, I think this makes sense in the face of global uncertainty. If you think back, companies were starting to kind of taking their engineering teams, shoring up the business interests, making sure that what the business needed to have done was in place, and it seems to reflect that teams started automating as much as possible, with the entire workforce was starting to head home. So there's a lot of shoring up of core applications, like as quickly as possible. So resolving the bug tickets that might be there, any issues, et cetera, in order to really lean on the stability of that platform. Now, if you think about what was happening in April of 2020, that was primarily lockdown mode in North America and a lot of Europe. And so we saw a lot more code going into the system. We also saw a lot more activity happening on the weekends than had previously been happening, along with more hours in a day where CI activities were taking place per project, roughly like 14 hours, where it had been 11 or 12, which can be reflected in the fact that there's no more commuting times. Now, where should your team land is kind of a question that gets asked. And software delivery cadence should be dependent on the software your team's building and on your business needs. Measuring your baseline throughput and then monitoring that for fluctuations will tell you more about the health of your development pipeline than aiming for some arbitrary throughput number or comparing your stat to others. It's important to set that baseline first and then see where the fluctuations happen. It can tell you a lot. Now, before I go into duration, the data we saw, there's a little caveat. Workflows with the shortest possible duration are not the goal. I said that earlier. For example, the shortest 10th percentile of workflows as measured by duration, they finished in under 30 seconds. Well, this may, provide adequate coverage in some scenarios. For most workflows, 30 seconds is not enough time for a robust test to run, especially if you're doing something with NPM and part of your test, you have to run NPM install. And that's definitely not happening in 30 seconds for any project. So, tests are what provides you with a rich understanding of any failed workflow. So test coverage and then that meaningful signal they provide should be the primary goal. Once that's established, you can then optimize for shorter duration. I hope that makes sense. Like getting your workflow to have and test coverage to be optimized. Then you go and look at shorter duration. So while we believe that duration is the most important metric to consider, we're not really interested in speed alone. The goal is confidence in the quality. And you can assure quality with robust testing. So that's the caveat. With duration, we see the mean falls heading into the pandemic, and it kind of stays steady. But the 50th percentile and above, the duration increases year over year with a slight dip in April, and then increases again in August towards the longest duration year over year. And what we're seeing that's indicative of that if you're shoring up your business, we talked about in this type of environment, you're adding more tests to your CI suite, you're more fine tuning of your code and even your CI tests. And in your testing, you're increasing your parallelization or optimizing right away to make sure that the application is as stable as possible. It also holds true as we see throughput also growing around this time. What duration should your team aim for? In our experience, duration between 5 and 10 minutes are going to be short enough to get information quickly and long enough to give your team the valuable insight needed when a build fails. Shorter than 5 to 10 minutes means your feedback might not really be complete, and you'd counterintuitively increase your time to recovery. Longer than this, and you lose the attention of your developers. While they're waiting for long tests, they're going to move on to other work. In that scenario, time spent in a failure state is going to extend. As they have to regain the context necessary to fix any issues that arise once those tests finish. So it's really important to really maximize for that 5 to 10 minute, as opposed to letting your durations run longer once you've got your testing down. Success rate. The importance here is going to be variable depending on the structure and size of your team and what's really being worked on. If a branch represents one person working on a topic or feature that no one else is relying on, a red build is really less concerning. On the other hand, if the entire engineering department is blocked from doing work until the main branch is green, then preventing red builds is going to be of paramount importance. So our data set includes workflows from both of these scenarios, and then really anything, everything in between. Success rate in the pandemic, when we look at that 50th percentile, there are some things that are always green, some things that are always red. What we see with this uptake in success rate for the 50th and 60th percentile is it's about the same year over year. This tends to show your typical red to green type of cycle as people are testing out new features, innovating, whatnot. No one expects every commit to be perfect every single time. And I think if that's your expectation, especially as a manager, I think you really need to reevaluate what's important for your team. A healthy, innovative engineering team tends to have somewhat of a high degree of failure, and that's okay. I want to really stress that. So when we see things like a peak, hear about the same time kicking into the pandemic, that signals that with the average engineering team, they're likely doing less innovation and more shoring up the core business, like resolving issues, bugs, et cetera. And when you're resolving bugs, you're going from red to green. You're getting more stability in the system. So we would expect to see a peak in success rate here. Then once the business is stable again, success rate is going to go back down, and you'd see more innovation or new feature branch development happening. Now, the lower bar here, the red that kind of trails off towards the end of last year, signals through the data that we've seen that people are starting to test out more automation tools, testing out their CI tools, and starting with a handful of commits where they're not likely to be very successful, so that they can see how things are performing. The other thing that's interesting about success rate is that success is the state you want to reach, and there are many ways to get to a failed build, but really only one way to succeed. So if you have something that is failing, you could push another commit, it could fail again, and then you push another, et cetera, doing that a few more times until you've now pushed 5 commits, which all fail, and then the 6th was a success. So now you're at a 1 in 6 success rate, which we see kind of trailing off here at the very bottom, towards the end there. The bottom line here is that success rates were basically the highest on record throughout April and May. And one thought that is the data science people started looking at that is that the level of distraction for many developers, like not going to conferences like this, no traveling, they started working on all the software and core business and shoring that up. Success rate can be an interesting statistic that can tell you a lot about how your teams are functioning and isn't always indicative of bad performance or bad process. Your workflow success rate is going to depend on the kind of get flow model chosen for development. If you're developing on topic branches for your team, that's the choice for your team, you should set a high target for success rate on a default branch with no expectation set for the non-default branch. Because if you're on topic branches, you're going to be failing. Many teams are accomplishing this with workflows that run on their default branch. In any case, the ability to measure the success rate of your kind of current workflows will be essential in establishing targets for your team. Key point here is remember that failed builds are not necessarily a bad thing, especially if you're getting a fast signal and your team can respond to those issues quickly. Which takes us to the things we saw with recovery time. The fastest mean times to recovery were on the order of a couple of minutes. Now, once again, kind of the absolute shortest possible time isn't necessarily the gold standard here. One way to get a fix this quickly would involve a developer knowing that they just submitted bad code and immediately pushing a fix while their original workflow is still running. Alternatively, it could indicate that two developers had pushed commits, which we talked about, minutes apart on the same branch, one that failed, one that succeeded. Both of these are somewhat unlikely scenarios for normal operation. As mean time to recovery is the second most important metric to consider, our goals should reflect realistic targets. So what we've seen with recovery time, and it kind of follows the same basic path from all the other metrics, is that they're declining. In the 95th percentile, we're seeing that year-over-year drop, a little one, but a big drop in April and May. Those are generally reflective of, if stability is the business's ultimate goal, especially during a pandemic, you're going to see this, especially with those commits that you're pushing during this time. With what we saw in the early stages of the pandemic was kind of an all hands on deck mentality and getting to resolve issues as quickly as possible, getting the signal back, and then mitigating issues and so on. And that's that feedback cycle that's at the heart of CI and rapid app development. Everyone wants to see a decrease in recovery time, but you see signals like we have in this plot here that come from the ability to bring everyone together and focus back on the core business and shore things up with the uncertainty, especially early in COVID times. The signal clearly is showing us that we had more developers pushing code, fixing issues, et cetera, and they had less distractions like conferences, travel, et cetera. Everyone's back on trying to get to the stability state that's important to the business. So what the data has shown us that some people were able to do more while at home, others were able to do less. Okay, so it's important to kind of set targets. And so, I talked about the baselines and kind of what we see for the median developer and then what it looks like for suggested benchmarks. So I have these here. Throughput, the median was 0.7 times per day. Our suggested benchmark to kind of start tracking things at is that you're merging on any pull request. Duration, less than 4 minutes. Suggested benchmark is to get really quality information is in the 5 to 10 minute mark. Mean time to recovery, that's the median was less than 56 minutes, and we're saying that the suggested benchmark from what we've seen is really under 1 hour, kind of fits that for how long it takes to resolve an issue, and then success rate. The median developer we've seen is really at that 80% for the default branch. We suggest kind of going for more like 90% or better on default branches. Notice that we're not talking about feature branches. We're just talking about default branches here where it really matters. All right, so now I want to go through some of the interesting tidbits that we've seen with this data, and some things that kind of make you go, First one, branch information. We're in an interesting position to be able to see how people are using their branches in development. During the pandemic, especially during June to July of last year, there's a lot of social unrest. Black Lives Matter protests rightfully exploded onto center stage. And part of that was a resurgence of an older discussion about the term master and slave throughout the tech industry and the important quest to find better language within tech and within our normal lives that's more inclusive. So with that, we wanted to look and take a look at the data and see, we asked our data scientists to see what they could find if the use of master as a default branch name or as a branch name itself decreased year over year. Of course, there was a lot of press around this, online petitions, a lot of discussion on Twitter. GitHub came, they published how they were going to change the default branch to main instead of master. There was just a lot of really good, productive conversation of how, like I said, in tech, we need to have better language. I can say that realistically, we've seen almost no real decline in the use of master as a branch name. Now, while I think that's sad, I think we're seeing more and more tooling default to better naming conventions. And so I believe we're going to see more of this in the near future. I hope to see this come in and be a change in our the next report. I think it's, a lot of companies understand the importance of making this change. It isn't as easy as just flipping a switch. There's a lot of things that have to be changed. And so I do feel with a lot of the conversation that was happening that we will see that. But over, last summer into August and September of last year, there was not really much of a meaningful change. Another thing we noticed with success rate was that there was a difference in success rate between branches, with default branch being higher than a non-default. And we kind of talked about that earlier. We saw success rates 80% on default branches at the 50th percentile, 100% for the 75th percentile and above. So what this really tells us is that a lot of the innovations happening on the feature branches, because 58% success rate for non-default branches at that 50th percentile. So once things were more successful, then they moved to the default branches and that success rate went up. So doing all the development and do all the testing on the non-default and making sure that the default branch was as valid and as successful as could be. Another thing we saw is that duration on default branches was faster at every percentile over the non-default branches. So this was telling us that the mainline branch people work on test engineering, working on making it fast, making sure the feedback is good, which also tracks with, we saw recovery time was lower on the default branch in every percentile, meaning people who were relying on mainline, they're watching recovery time a whole lot more to make sure that fewer people are impacted by a red build. So with that, understanding the development processes that really work. One thing we've seen is, when you look at organizations and how many contributors are in the organization, success rate really doesn't correlate with company size at all. If you have 800 contributors in your GitHub org, or you have 4, we can't really tell that just by looking at the success rate. Another thing we've seen is that duration is longest for teams of 1, which I think, makes sense. If you're just a team of 1, you aren't really a team. And secondly, you're probably not caring if it takes you a long time to get feedback because there's no one else waiting on you. So I think there's a little social construct here where when you know that you're in the way of someone else, you're going to do extra work to make sure that it's faster or better understood or taken care of in a better way so that they're not waiting on you. And those are some of the things that we miss when it's just one of us. It makes the duration longer. Recovery time decreases with the increased size of your team, which we found played out up to about 200 people in a team. Above that, the data is a bit fuzzy because we didn't see a lot of data with larger teams over 200 all at once in the same repo. So basically, the more people you're impacting with a red build, probably the faster you are to recover it. When things are red, you're holding up a lot of devs in their work. And so the incentive to get things resolved and back to a green build quickly is really high. In reverse, the longest recovery time, again, are from teams of 1, which again supports the idea that if it's just you, you're less inclined to quickly get things sorted. Or that's just me. In summary of these is that performance is better with more than 1 contributor. In every outcome we could measure, you're better with you, and if you have more people you're working with on X thing. And so the takeaway is that software is collaborative. This isn't new, but I don't think we talk about it enough. When we talk about data and metrics, it's a thing that we've been able to prove out. And when you look at the outcomes and success rates of team sizes and number of contributors that you have, you can see that putting more people working on a project is going to give you better outcomes. The other thing we kind of wanted to look at with this massive data set was, if don't deploy on Friday was actually, still a thing. It's not. People may say it is on Twitter, but it's not. Looking at the data, there was 70% less throughput on weekends, 11% less throughput on Friday. We used UTC to identify the days of the week so we could get a better all-encompassing view, and 9% less throughput on Monday, which is telling us people are still deploying on Fridays. So the next time you see the "don't deploy on Friday" on Twitter, chuckle and move on. Now, some of the things I wanted to kind of give a quick view into the data that we're now seeing for 2021 as it relates to the previous years, So I want to give a quick sneak peek here. Workflows with 0 tests increase, year over year, but they're decreasing as total of all workflows, showing that folks are continuing to find value and build automation. Workflows with tests are increasing, so folks are finding the need to move from build automation to CI, and seeing growth. And we're also seeing growth in folks that are deploying more deployments year over year as well, which is good. Deployment is starting to really drive. This implies that folks are getting good enough at CI to do, CD. As more folks move towards CD, change validation, really becomes necessary. Now, I mentioned the 2021 State of DevOps report that just came out. Again, I highly recommend you grab that, take a look at it. 50th percentile of folks that are on CircleCI make it into that elite performer tier that is defined by DORA. This has been the case since we started observing this data. So we see folks on the platform are improving year over year, and this validates that DORA has seen that the industry itself continues to recognize that they need to accelerate software development, accelerate what they do. The last one here is that Kubernetes usage with CI/CD has increased year over year. Well-tested code tested in the cloud is required for continuous delivery, and enterprise customers are getting this. It shows up as kind of in a lot of the biggest number of accounts. Enterprise customers, they feel the pain of bad software in users' hands more acutely due to the scale. And then the cost of a bad deployment compared to the cost of well-tested code is compared. They're both compared to cost of well-tested code being continually delivered. And at the enterprise scale, it is cheaper to test versus provide a bad service experience. So with more code that's continually being deployed, monitoring is more essential. Mitigating poor outcomes is an asset. And so the Kubernetes use and usage with CI/CD, that increase is really lending more support to the need for well-tested code that's tested in the cloud. So that's it. That's the full report. That's a good dump of that. There's a lot more information found. If you scan this QR code or go to circle.ci/SSD 2020, you will get to get that full report, get it in PDF form. You don't have to sign up for anything. You can just click the download button and that's it. You don't have to sign up for me to send you funny cat memes. If you want to, you can certainly reach out on I am Jaredog. You can find me on LinkedIn, Polywork, timeline.jaredog.me. And also, I'd love to hear feedback from you. Any questions you have, we can definitely dive deeper into that. Or if you just want some swag, that's great too. You can go to circle.ci/Jeremy. Or if you don't remember that, you can go circleci.com/Jeremy and immediately get, fill out a short form, give me some information and, what your feedback was, and I will get you some swag right out. So, yeah, I think that's about all I have, and we are at time. So thanks again. Thanks for coming to All Things Open, especially the virtual track, and thank you for supporting it. Without your support, not only would open source not be where it is today, but this conference wouldn't happen. So thank you, and I appreciate everything that each one of you have done. You're all great people. So thank you.